Here's a quick review of the Spud Lofter. It's a rocket I built specifically for the NSL West that was last weekend in Alamosa, San Luis Valley. And the objective is to loft a potato. You get to pick out a potato and get it numbered. You have to use a new potato for each flight and hit an altitude of 25 feet. That was the short one. There's another version of the contest that's 10 times higher than that. For the rocket, I was going to use some F&G motors that I had, and I simulated an open rocket. It was coming in a little low, so that colored some of my design decisions. The other thing was I started with 200-gram potatoes and actually bought a couple at the local grocery, and they were actually a little heavier. So I'll talk about that in a second, but let me walk you through real quickly the design. It's a 3-inch slotted tube. I was actually in the scrap heap at Apogee when I picked up some other stuff. So shout out to Tim and crew for shipping quality product and making stuff available that doesn't meet their standards for us to run experiments like this on. Here's the motor retainer. It's held on by 3 M3 stainless screws that are in tubes that are formed in the 3D print and tapped. So that seems to work pretty good. It's pretty sturdy. Didn't have any problems with that. The fin assembly is printed from this side up and is all one piece. So the fins are here. They're sort of pseudo through the wall, meaning that there is no internal motor mount cardboard tube. The printed assembly has sort of a cylinder in the back and then some veins in it that you can see on the Tinkercad to just hold the motor. Again, I was trying for very light. And one thing I want to emphasize is you have to have the potato. This does not have a center of pressure that is nearly as far back as I would normally design a rocket, because the potato was going to be sitting in the nose and a lot of weight there. I did go ahead and reuse something from, there's a couple pieces reused from the Pringles can rocket actually. One was this 1/4-inch sort of launch lug mount, and then the second one I just glued it right into the fin crevice here for strength. It's a little off because this was held up because of the geometry of the Pringles can, but that worked fine. I also put basically tapped, again, 3D tapped the holes in 3D nubs that are mounted on the back side of the tube, so I could use rails, and I launched it with both, and both worked well. I think the rail is better in terms of stability and speed. And in the nose cone, this is a little bit of a learning experience. So this is really a close version of the Pringles can. A Pringles can is not exactly the same size. The problem that I've had with this design, and I'll probably rethink it a lot, is just a lot of flying parts. The specific problem I had here was the launch site was pretty high, over 7,000 feet, and I wanted to use a pretty big chute, a 36-inch chute, with the potato as a added weight, and it wouldn't fit inside this shoulder compartment like before. So I did a more traditional thing. I put the parachute in the body tube, wrapped inside a fire protector blanket, and there's also the shock cord mount in there as well. That's sort of a ring that you can see again in the Tinkercad. Again, this was derived from the Pringles can. I just made a little kind of crisscross brace here to hold it, and that also helped me put the Firefly in to be able to monitor the height. One critical thing I've learned about this design is when I do this twist lock nose cone, you really need to put tape on it, and doubly so this time, because as you'll see in a second, the potato is riding in the nose cone. And sorry about that. So again, a twist lock. I put the potato on top of a piece of green foam that I got just in the floral department. So again, trying to hold it as far forward as possible, and it's in the nose cone. So it was in the very tip of the nose cone. There's the potato. Again, it was marked for the launch. and this was just at the launch site. I kind of hacked and carved it. It's a hard foam that again is in the floral site, so it worked out pretty well. The thing can't weigh a gram. It's super light, and again, that was kind of the crisscross I put on it. So that's pretty much the design. In terms of actual flights, I was able to fly it 3 times. The first flight I knew was an underpowered motor, but I just kind of wanted to test the design out with a motor I had. It was an F67. It turned out that since the potatoes were much smaller and I knew it was going to hit the height, I grabbed a much smaller potato, and then fortunately came to the realization to check again the center of gravity and center of pressure, and realized that wasn't enough nose weight. So I actually flew a second potato as ballast, just kind of stacked on top of one another. And that went to 1,200 feet as opposed to my sims of 1070. So I figured that was pretty close. The G40, I grabbed a bigger potato that actually would fit in the nose cone. And with the bigger motor, it went to 1991. So that was actually as close as I got. I haven't seen the results of it yet, but I'm pretty sure there was some hefty competition. So I doubt that's going to be a winner. And then, given that fell a little short, I went ahead and purchased on site a G77. That I think is like 105 Newton-second impulse, and this is 100, so just a little tiny bit bigger motor with a bit more of a kick, a slightly smaller potato, and I fully expected to go actually overshoot, but I undershot again. So I think this was probably just, this 1991 was a really, really nice straight flight before the winds kicked up. This one was pretty straight, but it arced over a little bit, so it was not as high. So those are the results, but the rocket performed well, and I'll figure out how to do some other things with it. I'll post append to this a video of the first flight and the third flight. Unfortunately, I don't have. I neglected to actually take a video of the second flight, but you can see how it flies.
3, 2, 1. Back to range left. We're going to start on bank 5. Doug Gerard is still preparing.
3, 2, 1.